All right, so when we talk about domain, we're mostly concerned with real numbers, right? So we want to be plugging in values that give us real numbers. For example, in this case, we have a square root, right? We know that if we take the square root of a negative number, we're going to get back an imaginary number. So when we talk about domain, our domain is the set of values that we are allowed to plug into a function. So it's our potential x values, values that we're allowed to plug in for x. So for this example, let's just say I wanted to figure out what's f of negative 6. And again, when you see this notation here, this just means I'm setting my x value equal to negative 6. I'm going to plug negative 6 in wherever I see an x. So that's equal to the square root of negative 6 plus 3. That's equal to the square root of negative 3, which, if we remember back to algebra, well, square root of a negative 1, right, square root of negative 1 is equal to I. And you can think of that I as standing for imaginary if you want. So that's equal to I square root of 3. This is not, again, this is not a real number, okay? We do not want this. So that tells us that negative 6, not in the domain of f of x, okay? It's not in the domain of our function here. So now your question might be, well, what is the domain of this function? So basically what we just found is we do not want to take the square root of a negative, okay? Whatever is underneath this square root sign here, we want that to be positive. Can you take the square root of 0? Yeah. Square root of 0 is just equal to 0. That is okay. All right, taking the square root of a negative number, that is not okay. So we know that we want x plus 3 to be greater than or equal to 0. Right? You could take the square root of 50, you could take the square root of any decimal. It doesn't matter. We just cannot take the square root of a negative number. So this tells us, well, that means we know that x has to be greater than or equal to. All I'm going to do is let's just subtract that 3 to the other side. Subtract that 3 to the other side. 0 minus 3 is negative 3. So we get x is greater than or equal to negative 3. All right, let's take a second to talk about interval notation. So you guys might be pretty familiar at this point with this symbol here, which means the set of all real numbers. Okay, that's what that R with the extra added line. So it's the set of all real numbers. Ooh, I can't spell, numbers. That says numbers. Okay, so the set of all real numbers. Well, the set of all real numbers in interval notation goes from negative infinity all the way up to infinity. This negative infinity is the lower bound.
The affinely extended real number system is obtained from the real number system by adding two elements.
Siri, what are you saying?
Do you want me to keep?
Sorry about that. Okay, and then the number to the right, this is our upper bound. Okay, so we want to include every single number between negative infinity and positive infinity. Okay, with negative infinity being our lower bound, there's no real number lower than negative infinity, and positive infinity being our upper bound. There's no real number that's greater than positive infinity. So this is how we would write all real numbers in interval notation. All right, so let's take it back a step. We said that the domain of this function here, right, f of x is equal to the square root of x plus 3. We said the domain of that function is x is greater than or equal to negative 3. And this is just a common notation for how I'm going to write domain, okay? Just a big D and then a colon. Okay, that stands for domain. So the domain is x is greater than or equal to negative 3. Well, let's put this in interval notation now. So I know that I'm going to have some some sort of parentheses on the left, right? And then a comma, and then some sort of parentheses on the right, with this being my lower bound here, and then this being my upper bound here. So the lowest number that I can possibly go to is a -3, right? I know that x has to be greater than or equal to -3. So if I took a look at that on the number line, right? If you had a number line here, well, this is my value -3 here. I want to include it, and then all the values up that way are okay. Okay, so what's going to be my upper bound? Well, my upper bound is infinity. I'm extending all the way to infinity. Now, the one thing that we do need to talk about, is the use of parentheses here, okay? If we notice up here, we have x is greater than or equal to, so we're actually not going to use parentheses. Instead, we're going to use a bracket, okay? We're going to use a bracket. This bracket here, if I highlight this bracket means inclusive. Okay, we are including -3 in the domain, right? X is greater than or equal to -3, so we want to include the value of -3. Over on this side, okay, it's still a parentheses. We're still going to have a parentheses because infinity isn't technically a number. You can't plug infinity in. So this is not inclusive, okay? Whenever we have an infinity sign, you always use parentheses. And parentheses means not inclusive. Again, bracket is inclusive, parentheses, not inclusive. All right, so let's take another look at an example. Say f of x is equal to 1 over x plus 2. Okay, we'll keep it nice and simple. In this case, well, now we have a fraction. What are we not allowed to divide by? You're not allowed to divide by the number 0, right? You can never have 0 in the denominator. Can't have 0 in the, and I'm just going to call it the denom. Okay, that stands for denominator. So you're not allowed to have 0 in the denominator. Well, let's figure out, when is our denominator equal to 0? X plus 2 is equal to 0. Okay, so x is equal to -2. And we know that we can't have that, right? That's not allowed. We don't want that. We don't want that. Okay, so in this case, the domain of x, that's going to be all reals, but x is not equal to -2. Okay, so now the question is, how am I going to write this in interval notation? I want to be able to write this in interval notation. Okay, let me just erase this so I can have a little bit of room to work with. All right, so I want to take this right here, put it in interval notation. Well, I know all reals is -infinity to infinity, right? But now I want to exclude the value -2. So what I'm going to do is I'm going to take this, right here, and I'm going to split it up, okay? I'm going to say, well, let's go -infinity up to -2, right? This being my lower bound still, and now this is my upper bound. I do not want to include the -2, so that's why it's just a parentheses here, okay? And then I also want to have all the numbers -2 up to infinity, okay? Right? That makes sense. You just want all the numbers from -infinity up to infinity, but we need to exclude this value -2, right? Because -2 is going to make the denominator equal to 0. We don't want that, okay? Do not want that. So the last thing with interval notation that we need is we are going to include this u, Okay, we include this u whenever we have multiple intervals. This u means union. Okay, so we are taking the union of the interval negative infinity to negative 2 and negative 2 to infinity. Okay, we need both of these intervals, and we are going to use this u to include both of them. All right, let's make things a little bit trickier now. Let's say, well, I'm going to have f of x is equal to square root of x minus 4 over x squared minus 9. All right, so things just got trickier. Now we need to take into account two things. Okay, I'm going to take into account my square root here, right? X minus 4, square root of x minus 4. And I know with square roots, well, I cannot take the square root of a negative, right? That's going to be an imaginary number. We are only dealing with real numbers. So, square root of x minus 4, that tells me x minus 4 has to be greater than or equal to 0. Okay, so then x is greater than or equal to 4. Right? So this is one thing. We know this has to happen. X has to be greater than or equal to 4. Now, I also know my denominator cannot be equal to 0. Right? If I take a look at my denominator here, let me shade that in green, highlight. Okay, x squared minus 9 cannot be equal to 0. X squared cannot be equal to 9 then, right? I'm just adding 9 to the other side. So, well, when is x squared equal to 9? X cannot be equal to positive or negative 3, right? A negative 3 squared is 9, a positive 3 squared is 9. So now we know x squared cannot be equal to a positive or negative 3. Well, with this problem, we know these both have to be true. Okay, so I somehow need to create an interval that combines the both of them. So let's start with this one here that says x has to be greater than or equal to 4. Well, that's just going to be 4 inclusive, right? I want to include, use a bracket because it's greater than or equal to. And we're going all the way up to infinity. Well, I also know x cannot be equal to positive or negative 3. Do positive and negative 3 fall on this interval? No, they don't. Okay, so this is it. This is our answer. Our answer is 4 inclusive to infinity. We know that all of our x values have to be from 4 up to infinity, and we are including that 4 again. All right, so let's take a look at another example, and this is pretty much as complicated as they're going to come. So find the domain of g of x. And again, this is okay. G of x, that just means function, right? G is just some other function. You're not always going to see f of x. Don't just take f. If I give you g of x, don't just cross off the g and write f, okay? Leave it as g of x. Be comfortable with seeing it as g of x, okay? So g, that's just a function, right? Don't worry the fact that it's the letter g, okay? It's still a function. All right, so if we take a look over here and we notice, okay, again, we have two restrictions, right? One, we have this square root. Whatever's under the square root has to be greater than or equal to 0. We do not want to take the square root of a negative. So that tells us, here, let me just block this off. 4 minus x squared has to be greater than or equal to 0. And then if I take a look at the denominator, well, I know my denominator can't be equal to 0. We are not dividing by 0. Okay, so I know x minus 1 is not equal to 0. All right, let's start off with this one over here. This is probably easier to solve. X minus 1 is not equal to 0. Well, let's just add 1. Add 1 to each side. X is not equal to 1, right? Makes sense. If I plug 1 back in, 1 minus 1, that gives me 0. Great, so x is not equal to 1. I'm done there, okay? Over here, this is where things might get a little bit tricky, okay? We need to be careful when we're trying to solve this. So let me show you first what not to do, okay? All right, well, I have 4 minus x squared is greater than or equal to 0, so I'm going to add x squared. 4 is greater than or equal to x squared. Okay, now let me take the square root of each side. X is less than or equal to 2. And then, you have some people who do think, okay, well, if I take the square root, I have to do positive or negative. So x is less than or equal to 2, or x is less than or equal to negative 2, right? And again, this one and this one both say x is less than or equal to. It's just because here I wrote the x second, while over here I wrote the x first, okay? But does this make sense? Let's take a look at it on a number line. Okay, so I'm saying my x value has to be less than or equal to 2 or less than or equal to negative 2. So let me just say, well, this is my value 2 here, and then we'll say negative 2 is somewhere over here. Right? Doesn't really matter that I don't have it drawn to scale. So if x is less than or equal to 2, that's this line here. Ooh, that was bad. Or x is less than or equal to negative 2. Well, that's this line here. Does that make sense? It doesn't really make sense, right? These arrows are overlapping. We don't really want these arrows overlapping, right? And if I plug in a number, let's say I pick some number that falls in this range here. Let's just say 0, right? 0 falls between negative 2 and 2. If I plug that in, 4 minus 0 squared, well, that's 4, and that is greater than or equal to 0. So that works, right? 0 works. What if I pick a number over here? Let's say, I don't know, negative 5. 4 minus, well, negative 5 squared is 25. 4 minus 25. Is that greater than or equal to 0? Definitely not, right? Negative 21 is not greater than or equal to 0. That does not work. Okay, so this range here that's all wrong. Okay, so let's take a step back. Let's just erase this. Erase, 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 erase. Okay, and some of the steps in there, yeah, they seem like valid options. However, let's take a look at this in a different way. What we're going to do is very similar, and we're going to actually see this later on in the year too. So if you practice it now, by the time we get to it later on in the year, it'll be really straightforward. First thing we're going to do is find, well, not when is it greater than or equal to 0, but just when is it equal to 0. So when is 4 minus x squared equal to 0 instead of greater than or equal to, okay? Then you can solve it, right? 4 equals x squared, so x equals positive or negative 2. Then you're going to do exactly what we just did. Let's put those numbers on a number line. Okay, throw negative 2, throw in 2. Okay, and again, the scale doesn't really matter. Then what we're going to do is just pick a number that falls in each of these intervals. So here, right, this one here, we want to be less than negative 2. So I'll pick, well, before I picked negative 5, I'll just do that again. Pick negative 5. Here, pick 0. Here, let's just pick positive 5, right? Then what we can do is take this value, like we did, and let's plug it in right up here, just like we did before. Does it make this true, right? That's the question. 4 minus negative 5 squared is greater than or equal to 0. Does it make it true? 4 minus 25, that's negative 21. That is not greater than or equal to 0. So I'm going to draw an X there, right? It's not true. 4 minus 0 squared, yeah, that's greater than 0. And then again, let's take 5 and plug it in. 4 minus 25. Is that greater than or 0? No. So what satisfies 4 minus x squared is greater than or equal to 0? Well, only between negative 2 and 2, right? This is the only portion that satisfies it. I know at negative 2 it's equal to 0, at 2 it's equal to 0, so you have to be between it to satisfy. So x is less than or equal to 2, but greater than or equal to negative 2. Okay, so I have this piece of information. Here, let me do that in a highlighter. Okay, I have this piece of information. And I also have this piece of information. x is greater than or equal to negative 2, but less than or equal to 2, and x is not equal to 1. So in the next portion, let's figure out how can I write this in terms of, how can I put this in interval notation? All right, so now just taking a look at this, I have x is not equal to 1, and then x is greater than or equal to negative 2, but less than 2. So I want to be able to write this in interval notation, right? I want to state the domain in interval notation, so let's take a look. Let's start with, well, I know I have to be between negative 2 and 2, right? That's what this tells me here. I need to be between negative 2 and 2, and I'm going to include negative 2 and 2, right? Because it says greater than or equal to, less than or equal to. You can include both of those. But now I need to exclude 1. 1 falls in this range, right? 1 falls in between negative 2 and 2. I want to exclude 1. So what I'm going to write is, well, still negative 2 up to 1. And then, am I going to have a bracket or parentheses here? Well, I'm going to have a parentheses. I do not want to include 1. And then I'm going to go union from 1 up to 2. Okay? One thing that some people will get tripped up on is they'll write negative 2 to 0 and then union 2 to 2. Okay, this is what they'll write. Because they say, well, I don't want to include 1, but I do want to include 0. I don't want to include 1, but I do want to include 2. Right? Well, if we do this, we're excluding all of those numbers between 0 and 1, right? Like 0.5. Does 0.5 work? Is 0.5 in the domain? Yeah, 0.5 is definitely in the domain. If I cap it at 0 and say include 0, you're leaving out all of those decimals between 0 and 1. So this, no, do not do this. Do not do this. Okay? This up here, good. That's your right answer. We want from negative 2 to 2, but we're excluding 1. Okay? That's what this portion essentially does, is it says we don't want to include 1. All right, so we're going to finish this off with just one more example. So the example says, find the domain of h of x. And it gives us h of x is equal to square root of x minus 3 plus 2, okay? And just note that this plus 2 here is outside of the square root. So here, is this plus 2 going to affect our domain at all? Okay, no. No, it doesn't affect our domain at all, right? We still just care about, well, what's going into this square root. Okay, what's underneath the square root? We know that that has to be greater than or equal to 0. So let's take x minus 3. That's greater than or equal to 0. So x has to be greater than or equal to 3, right? I'm just adding 3 to each side. X is greater than or equal to 3. Let's practice writing that in interval notation. Okay, so I can say my domain is 3 inclusive again, right? This is inclusive because it said greater than or equal to, and up to infinity, okay? And again, we are never ever going to have a bracket on infinity, right? You can't include infinity. It's not necessarily a number, okay? Now, what my goal is to show you, well, what does this look like on an actual graph, right? What is the domain on a graph? So let's head over to this graphing calculator app that I got for free, Desmos. And we are just going to plug in, well, let's graph square root of x minus 3 plus 2. Oh, I forgot to take that out. Let me go back. Oh, I need to get rid of that plus sign. Back. Okay, plus 2. Okay, so now if you look in the upper left, you can see I have graphed square root of x minus 3 plus 2, and it's an implied function. Okay, it implies that there's an f of x up there. Okay, and as we said earlier, right, when we talked about functions and just the intro to function lessons, it said, well, the domain is really the x values. It's what can you plug in. So if we are looking at the graph, right, this here is my graph of square root of x minus 3 plus 2. Well, where's it start? It starts right at x is equal to 3. At that point, yes, y is equal to 2, and we will get into that with range in a second, okay? But the first x value is 3, and then it extends all the way until infinity. And obviously, I could scroll forever and ever, and I would never get to infinity, okay? But it's just going to keep on going and going and going. So that's why it's from 3 to infinity. I just wanted to show you that visually, so now you can look at a graph and say, okay, well, the domain is clearly from 3 to infinity.